Well, it says we're live. Let's check our, yep, we got a preview window. Let's see if we have, oh, sound is like screwed up right now. So I won't be able to hear that here, but OBS does say that we're getting sounds. That's a good thing. And chat is all set up and ready to go. All right, so I started about a minute early, so we can sort of wait to see if anybody is joining. Yesterday, unfortunately, the power to the apartment I live in went out, which is really, it's really rare. I don't think that's happened at this apartment complex that I've lived in at all. So waking up feeling, it's lighter outside than I usually wake up, and then looking at the alarm and seeing it flashing 00. That's never a good feeling. And it was like 6:55 this time, so I was like, "There's no way I'm gonna wake up and get to a stream in time." So that was yesterday. But today we're back, and then next week we're going to experiment with Twitch TV for streaming. Good morning, Avarice. Welcome to the stream. All right, and I've delayed long enough that it's actually 7 o'clock now, so I think we can begin. So, what do I want to do for this? I want to go probably figure out what I was doing. It's been like a day and 2 days. Let's just fin the README. Okay, so we're on chapter 8.2, appending to a string with push string and push. And then I think this reminds me, I had GitHub issues. And also, like, the last time I said, like, hey, does anybody have any suggestions for practicing or something like that? Danny responded to that video with a comment talking about Project Euler and Advent of Code. So if you haven't heard, Advent of Code is a Christmas-themed code challenge website. It has an entire story about how you're trying to save Christmas. And it's just all problems that get more and more difficult as time, like, as they go on. And I think there's like 25 challenges. But with this, let's I want to go find the GitHub repo, because there was a really nice I think it was an issue or a pull request or something in that. So let's go find that. Into GitHub we go. And it might have been you, Avarice, but it's been like 2 days and it's early in the morning and I can't remember what this second. So learning Rust. Was it one of the issues? Nope. Pull requests. Yes. Okay, Avarice, it was you. And you have a pull request for us. So you added some comments to 2 days ago code, since at one point you missed that you only moved a reference into a vector and reached a false conclusion based upon this. So I did look at the code and I was like, oh yeah, you're totally right. I think, I'm not trying to remember exactly what was going on in my mind through this. I think I had, at one point in time, was passing in a reference to it, and then I decided to do something else, and I didn't review what this part was. I only changed down here. And yeah, so it did something else. So basically, here you only push a reference to my number onto the vector. So yeah, it's the ampersand, so it becomes a reference. Also, I realize this is on the right-hand side, so that I'm probably blocking it. Let's, instead of diff, we'll do unified, apply and reload. Here we go. This is easier. Okay, so here was then my my string right here. Because of the reference, you can just index into the vector and move the value out of it. The reference gets copied. Immutable references are copy types. Try and move the string itself into the vector, you will get an error that you cannot move it out of the vector like this, since it would leave the first element in an invalid state. So what I thought was that I was leaving the first valid in an invalid state, but that was okay. But apparently that's not the case. Instead, if you want to take elements that do not implement the copy trait out of the vector, there are methods that you can use. Pop remove or swap remove, which is sort of at the very end. They showed, oh, we're going to be using things like pop. So we have another string, and then prints my string of that length. The length is unchanged. The value position at 0 is no longer valid, which is not true. The length is unchanged since the reference to my number is still in the vector. So then he just removed my comment because it is not a good comment. Print line another string. So excellent pull request. Thank you, Averis, for this. I am going to merge this in. Okay, so we've got that in. Let's make sure I pull down the latest version of this code. And I sort of want to, you say that there's going to be an error if I try to move something into the vector. I want to make sure I fully understand that, or at least show off. We're on chapter 8. Vectors. Let's open up code here. Okay, so we could see that at this point in time, we attempted to push a reference to my number. If I comment this out and I say, okay, well, my strings dot push, and I just put my number in it. So just doing this on its own, then this is going to be pulling it out, which should be the problem. And if I save this, cannot move out of indexed content. So it won't let you move at all. So I think that's a I'm going to leave it this way because otherwise it will be really confusing with the wording there. But yes, I do like the fact that if you attempt to move into it, or actually you can move into it, I think that's fine. You can't move out of it because then the entire vector is invalid at that point in time. So it won't let you do that, which is really nice to sort of like know that protection is there, and I hadn't just accidentally stumbled on some way to do something bad. All right, so saving that. No changes with GitHub. Let's go verify where we were again. Cats true. We're on chapter 8.2, appending to a string with push string and push. Okay, so Rust book. Okay. Interesting. Since the last time we've been to the site, they changed the look of it. It used to have like the two different versions right here. Well, now it's showing that this is the new version that we're going with. So we're coming down to 8.2 strings, and it is appending to a string with push string and push. Did I miss something? All right, I think I did. Let's just actually copy and paste to find. Here we are. Appending to a string. Oh, and +1 for maybe doing some advent of code exercises. I really enjoyed doing most of them. Okay, so I will add that to a potential list of those things. Um, I don't know if I'll do them down like that. That might be perfect to do sort of like in between these different chapters. Especially if there's like certain things to do, or wait until the end. You haven't done anything with Project Euler though. It's basically just simple math problems. They don't act like there's no code checking. It's just like I think it's just like advent of code where you just put a number in. You can even use pencil and paper if you know the math behind it. But there's things like add up all of the odd numbers in the Fibonacci sequence that starts with 3 instead of 1 1 or something like that. It gets very interesting. Okay, so appending to a string with push string and push. We can grow a string by using the push string method to append a string slice, as shown in listing 815. So let mut s, so mutable variable s equals string from foo, s.pushString bar. So we just add, no, it's foo bar. After these two lines, s will contain foo bar. The push string method takes a string slice because we don't necessarily want to take ownership of the parameter. For example, the code in listing 816 shows that it would be unfortunate if we weren't able to use s2 after appending its contents to s1. Let mut s1, let s2 equals bar, s1.push string s2, s2 is s2. Right, so it would be unfortunate, but it's not. Like, we can do this. It doesn't, it takes a string slice because we don't necessarily want to take ownership of the parameter. So it sounds like, oh, okay, I see. Because s2 is not string from. It is just a stir. So if it is a string from, it would take ownership. Is that what they're saying? Let's find out. So, chapter 8, cargo new strings. Created. Strings. We'll open up code right here. And also the vector one, I don't need open anymore. All right, so let's play with some strings here. I have potentially a different idea for how to do this and like make it a little bit easier for us. Is instead of putting everything into main, we can just call functions that don't necessarily return anything. They'll just like do all the, like they'll be self-contained code that's titled. So we'll do this. We'll call pushing strings like that, and function pushing strings. We don't take anything in and we don't return anything. Okay, so if we have let mutable string 1, and this is going to be equal to string from, and then we take, so I've also heard like this can be called like string slice. So like the literal, I mean, this is a string literal, but it's also a string slice once it's into a variable. There's a few different ways to name it, and I'm not sure how I feel about that, because it makes it hard for me to be able to know which one to use in my mind to have the correct mental model. Although oftentimes I think that's just a problem that I have. mainly because I am dyslexic, and those type of things where it's like, oh, choose one thing, the name is sort of similar to both. It's kind of how English has many ways to say the same thing, which is not necessary, but they're sometimes wrong. Like, don't use that even though it's exactly the same pronunciation. Okay, let mute string one, string from, and we're gonna go hello. And I don't like the foo and bar examples. So we have, I'm gonna call this my hello string, and we're gonna say this is gonna be world equals, and this is just a string literal that we're handing here, so world. And then we want to put this together, so let hello world is going to equal to hello. Oh wait, I don't think it's that. I think it's, we just say hello.push world. And then we can print to this. James, welcome to the stream. You found this channel by chance? Have you shared this on our Rust? No, I don't. I'm trying to think. I haven't really been on Reddit too much recently. I think I took a look at Rust when I first started looking into it, but I haven't posted anything there at all. Okay, so I think one thing that I remember is that when I first went in, I looked to see if there was a Learning Rust subreddit, and I didn't find one at all. There was just like Rust, which I thought was interesting. But thanks for stopping by. Okay, so we push hello. Oh, I mean, you don't like this. Mismatch types, expected char, found string. All right, what did I do wrong? Push string, not just push. Okay, so push is for characters only. We need push string. And that allows us to push this word onto here. So now I can print. So print line. And this is going to be the variable hello now is hello. And we can do the same thing with a print line and say the variable world is, to show that it's still usable at this point in time. All right, so let's go ahead and give this a shot. Cargo run. The variable hello world is now hello world. The variable world is world. I vaguely remember, did I say that the plus operator can be used on strings to concatenate too? So if I push string world like that, can I do something like this? Will this work? I mean, I was going to say, I don't see an error, but binary operation plus cannot be applied to type borrow of stir. Plus cannot be used to concatenate two stir strings. To owned can be used to create an owned string from a string reference. Okay, so I think what it is that we can only do this on other types. So that's good to see. Okay, so we have this. So these are still usable. Now, if I wanted to add one more thing onto here, so if I say let I wonder if I can do space with this. So let space equals, and I'm going to do string from like that. So this is a full string. So we're going to do maybe before hello push world, we're going to do hello dot push string and hand it space. So now we have a couple different things going on. We begin with mutable hello, which is a full string. Then we push into it another full string. And then we push on a reference. And we're getting error here. Mismatch types expected borrow of str found struct standard string string. So it doesn't allow us to pass in a full string. We need to pass in a sort of a string slice. So consider borrowing here. So if we borrowed it, then that should work because of like ownership things. So that's like different ways of dealing with it. We can also just make sure print line, the space is still here as well. And I think what I can do is pipe, so to show that the space is there, space, save this, we'll run this as well. And the space is still here as well. So now it's hello world. Okay, so what do we really have here? We create our hello from here. Let world equals a string, a stir. Let space equals string from. So now we have two of those. For plus to work on strings, the value on the left-hand side needs to be a string instead of a stir. But this will move the string, so you need to assign the result to a variable or use it otherwise. Interesting. I would think that this is a string and not a stir. But I think what you're saying is that it needs to be assigned to a new thing. It can't be pushed in. But plus equals also works on strings and modifies in place. Wait, I don't have to do... Oh yeah, plus equals is like equals. Okay, yes. I got that. Thank you, Averis. Let world, that space equals this. Okay, so hello push string. We are pushing the we're pushing the reference to the space string onto the end of hello. Kind of like this is long enough comment that I kind of want to put it up. Okay, so push this. Now we are trying pushing a, and this is not a reference, this is just a full string to the end of hello. And both of those work. And then print line, all our variables are still usable. All right, so we've got that. And a little bit of annotation to sort of help us out. I'm going to see if I can try to do this style for our examples from now on, because I think that this will make it a little bit cleaner for us, and we'll be able to do these experiments and not necessarily completely destroy ourselves when trying to sort of change things around. Okay, so moving on. If the push string method took ownership of S2, we wouldn't be able to print its value on the last line. However, this code works as we'd expect. The push method takes a single character as a parameter and adds it to the string. Listing 817 shows code that adds the letter bar to a string using a push method. I think that, oh, L, that's what that is. Oh my gosh, I did not like that font. And then I think that we can also just do that here too. We can say let end equals, it's a character. And we'll now push on. Push is used for characters. Hello.push end. We'll save that. Rerun it really quickly, and there we go. This space is the variable hello is now hello world. Bang. As a result of this code, S will contain lol. I always pronounce out lol because it feels like a word. Although I know a lot of people that will just say LOL, which is too much work for me. Too many syllables. Okay, concatenation with the plus operator or the format macro. All right. Often, you'll want to combine two existing strings. One way is to use the plus operator as shown in listing 818. Well, that's what I kind of try to do before even reading this. I've been doing that a lot with this book. All right, so we have let s1 equal string from hello, comma, space. Let s2 equal string from hello world. What's interesting is that these are both full strings. Let s3 equals s1 plus reference to s2. Note s1 has been moved here and can no longer be used. All right, so that's interesting. We should probably do something with that here. So concatenating strings. So the thing that I find interesting about that is the fact that we're moving in one. Now, can I do a borrow to that too and then have it not be moved? Sort of like the second one. So if we do the same thing where it's, I'm going to grab this here and we won't do mute at first. So it'll be exactly the same thing. And we'll have hello and world. And do world, and then we'll do let hello world equals hello plus world. So expected a borrow stir found structure full string. So even though I have this right here, it requires us to not give ownership to this. So I need to give it a reference here, and then this one is not usable. So let's now print. So we have hello. We know that world is going to work because we only gave it a reference, so it's not going to be changed at all. And we just want to take a look at hello world too. So print line, hello world. Okay, and I should get an error here because this hello is now no longer valid, right? It got moved. Value used here after a move. So this would causes an error because we moved hello to hello world. Also make that a comment. Okay, so I find that's interesting. I find it also interesting that we can't do like this one. Now you were saying, Averis, that we can just do plus equals, right? So if I didn't do this, could I do, so this is probably gonna have to be a mutable hello. Then we can say hello plus equals world. But it won't be plus equals world, it'll be plus equals reference to world. And then that will work. Now, of course, hello world doesn't exist anymore, but this is how we would have to do it. So let hello world equals world. So it's caused an error because we moved hello to hello world. So I'll comment this one out. This works, and I can do another another way is to use plus equals. So we can do, that doesn't need to be mutable. We can do mutable here. So hello world plus equals to end, which end is going to be, so let end equals, it's going to have to be a reference to it, and it will just be string from exclamation point. And that should work, which sort of like updates hello world in place, like you were saying, Averis, and now our print line works. Yes, exactly. The string S3 will contain hello world, bang, as a result of this code. The reason S1 is no longer valid after the addition, and the reason we used a reference to S2 has to do with the signature of the method that gets called when we use the plus operator. The plus operator uses the add method, whose signature looks something like this. Okay, so it's actually calling a function, like a method on strings that's implemented on strings, sort of like behind the scenes. Function add takes in self, takes in a string that's a reference to a string, so it has to be a reference to a string, and then returns a full string. This isn't the exact signature that's in the standard library. In the standard library, add is defined using generics. Here we're looking at the signature of add with concrete types substituted for the generic ones, which is what happens when we call this method with string values. We'll discuss generics in chapter 10. That's in 2 chapters. The signature gives us the clues we need to understand the tricky bits of the plus operator. Okay, so it's not like is it going to be generics? Does generics mean that like it essentially can work with different, like the many different types? Sort of like what we ran into in chapter 3, where I'm trying to remember which thing. It wasn't option T. It was something else that we were running into, where it's like, oh, you can't do that. There's it looks for this one, this one, this one, this one, but you have to like let it know which one you're using. First, S2 has a ampersand, meaning that we're adding a reference of the second string to the first string, because the S parameter in the add function, we can only add a a reference string to a string. We can't add two string values together. But wait, the type of reference s2 is reference string, not reference str, as specified in a second parameter to add. So why does listing 818 compile? Well, because they sort of are kind of work together. I mean, we've been able to do that before, where just hand it a reference to a string to a function that we created that took a reference to str. The reason we're able to use reference s2 in the call to add is that the compiler can coerce the reference string argument into a reference str. When we call the add method, Rust uses a deref coercion, which here turns reference s2 into reference s2. I'm not sure how to pronounce that, but it's going to basically... Oh, we used the dot dot before, but that was in a for loop to like go through numbers. We'll discuss deref coercion in more depth in chapter 15. Because add does not take ownership of the s parameter, s2 will still be a valid string after this operation. And it can't take ownership because we handed it a reference. Second, we can see in the signature that add takes ownership of self because self does not have an ampersand. This means s1 in listing 818 will be moved into the add call and no longer be valid after that. So although let s3 equals s1 plus reference s2, it looks like it will copy both strings and create a new one. This statement actually takes ownership of s1, appends a copy of the contents of s2, and then returns ownership of the result. In other words, it looks like it's making a lot of copies, but it isn't. The implementation is more efficient than copying. It's a method from the add trait. You can also implement that for your own types. Oh, interesting. If we need to concatenate multiple strings, the behavior of the plus operator gets unwieldy. So we have three s's, let s equals s1 plus dash plus reference s2. Okay, yeah, that's pretty unwieldy. At this point, s will be tic-tac-toe with all the plus and quote characters. It's difficult to see what's going on. For a more complicated string combination, we can use the format macro. Okay, so format is sort of like print, but it will return a string. Yeah, it returns a full string. The code also sets s to tic-tac-toe. The format macro works in the same way as print line, but instead of printing the output to the screen, it returns a string with the contents. The version of the code using format is much easier to read and doesn't take ownership of any of its parameters, which is interesting because I noticed they're not passing in references to this. So I kind of want to make a note of this in here. So using format okay, so let's say we have these three strings, which we kind of have hello world here already, so we'll just copy this and use it again. Okay, so we have hello world, and we want to now say let hello world equals format. Interesting that code isn't aware of it. It's aware of some things from Rust, like the print, but it doesn't know how to do format. Okay, so I will then just say this. I don't have to have the space in here anymore. It's just going to be this space this bang, and then we're going to have hello and a world, and now we can print line using format and this will be hello world. And then here it's going to be print line, we have not lost hello or world. So this will be hello or world. All right, let's try this. Cargo run, and using format hello world. Okay, so perfect. Like print line, format does auto reference its parameter in order to not move them, which is very nice. So it does tell us this there. I'm surprised it just waits until the very end to tell us. All right, indexing into strings. In many other programming languages, accessing individual characters in a string by referencing them by index is a valid and common operation. However, if you try to access parts of a string using indexing syntax in Rust, you'll get an error. Consider the invalid code in listing 819. Okay, so right, so if we want to index something far away, so let s1 equals string from hello, let h equals s1 0. So that theoretically attempting to use index syntax with a string. So we want to get the h, but it says we can't do that. Oh, it didn't. Interesting. It made this have to scroll horizontally. The error and the note tell the story. Rust strings don't support indexing, but why not? To answer that question, we need to discuss how Rust stores strings in memory. So, well, I mean, the full strings, it throws those into the heap. Ooh, I lost my preview window. No drop frames, so it's still sending out data. So hopefully that's just YouTube preview being weird. Gonna refresh that, make sure that's still working. All right, good, we're back there. Internal representation. A string is a wrapper over a vector U8. Let's look at some of our properly encoded UTF-8 example strings from listing 814. First, this one. Let length equals string from hola dot length. In this case, length will be 4, which means the vector storing the string hola. Oh man, it just lost my preview window again. All right, I'm just gonna ignore it this time, and hopefully nothing is going wrong. In this case, length will be 4, which means the vector storing the string hola is 4 bytes long. Each of these letters takes 1 byte when encoded in UTF-8, but what about the following line? Note that this line begins with the capital Cyrillic letter ZE, not the Arabic number 3. Oh, this. Let length equals string from, and then a Cyrillic length. Asked how long the string is, you might say 12. However, Rust's answer is 24. That's the number of bytes it takes to encode that in UTF-8 because each Unicode scalar value takes 2 bytes of storage. Therefore, an index into the string's bytes will not always correlate to a valid Unicode scalar value. To demonstrate, consider this invalid Rust code. So let hello equals this. Let answer equals reference to hello 0. So before they were trying to access just plain from string, and this time it's from a string slice or a borrow or a reference string. What should the value of answer be? Should it be 3, the first letter? When encoded in UTF-8, the first byte of 3 is 208, and a second is 151. So answer should in fact be 208, but 208 is not a valid character on its own. Returning 208 is likely not what a user would want if they asked for the first letter of the string. However, that's the only data that Rust has at byte index 0. Users generally don't want the byte value returned, even if the string contains only Latin letters. If reference to string literal hello and then index 0 were valid code that returned the byte value, it would return 104, not H. To avoid returning an unexpected value and causing bugs that might not be discovered immediately, Rust doesn't compile this code at all and prevents misunderstandings early in the development process. That's something that C does, is it allows you, like, you're just like, it's just the like the Unicode value. Let's just play with that. And you can do all sorts of cool things, like take a character and add 1 to it, and then it's a new character. There are some small hiccups in the stream, but nothing major. Well, hopefully everything is doing good. But if we go down, let me know. I mean, it's not saying any drop frames whatsoever. So at least it doesn't sound like it's on my end. Bytes and scalar values and grapheme clusters. I'm not familiar with grapheme. And I guess I missed the last part, which is, oh my. Another point about UTF-8 is that there are actually 3 relevant ways to look at strings from Rust's perspective: as bytes, scalar values, and grapheme clusters, the closest thing to what we would call letters. If we look at the Hindi word, oh, I don't even know where to start with that one. I don't know how to pronounce I don't know how to read Hindi. So written in, I guess this would be, that's not Hindi, that's Devanagari. Is that how to pronounce the script type? It is stored as a vector of U8 values that look like this. So it's like 224, 164, 168, and so on. That's 18 bytes and is how computers ultimately store this data. If we look at them as Unicode scalar values, which are what Rust's char type is, those bytes look like this. Right, which is sort of like the way I like to think of chars, is like the single thing that you want to pass around that's abstracted out. There are 6 char values here, but the 4th and 6th are not letters. They're diacritics that don't make sense on their own. These 2. Finally, if we look at them as grapheme clusters, we get what a person would call the 4 letters that make up the Hindi word. Okay, maybe not. Maybe I would probably normally think that this is the char. That these are the characters. So that's, yeah, I could see that this causing a little bit of confusion. Rust provides different ways of interpreting the raw string data that computers store so that each program can choose the interpretation it needs, no matter what human language the data is in. A final reason Rust doesn't allow us to index into a string to get a character is that indexing operations are expected to always take constant time. O of 1. So indexing a string is always expected to take constant time, but it isn't possible to guarantee that performance with a string because Rust would have to walk through the contents from the beginning to the index to determine how many valid characters they were, which would be O of n. Okay, so you're saying substitute are were, and that was something back here somewhere. Okay, slicing strings. Indexing into a string is often a bad idea because it's not clear what the return type of the string indexing operation should be. A byte value, a character, a grapheme cluster, or a string slice. Therefore, Russ asks you to be more specific if you really need to use indices to create string slices. To be more specific in your indexing and indicate you want a string slice, rather than indexing using square brackets with a single number, you can use square brackets with range to create a string slice containing particular bytes. I think we did that a while back. So we have this let hello and let s equals a reference to hello where we have 0 through 4. Here s will be a reference stir that contains the first, so I guess we'll say a string slice that contains the first 4 bytes of the string. Earlier, we mentioned that each of these characters was 2 bytes, which means S will be 3A, or whatever. I don't know if I can actually say that that's A. It just looks like it to me. Oh no, I meant that there were hiccups. It seems to be fine now. Okay, cool, great, perfect. What would happen if we used hello 01? The answer, Rust would panic at runtime in the same way as if an individual index were accessed in a vector. Byte index 1 is not char boundary. It is inside this character, byte 0 through 2. Okay, so it literally tells you, hey, you can't do that for that specific time, but it would panic at runtime because as far as it knows at compile time, you're not going to have a strange string in there. And I guess this strange string is not the right words. A string that's not just, I guess it's not making any assumptions about what kind of data you have. Okay, so you should create ranges to create string slices with caution because doing so can crash your program. Yay. All right, so let's just go over this last section and it'll be, well, actually we only have these 2 last little bits and then we're done with this chapter. No, we're not done with this chapter. We're done with 8.2. Okay, methods for iterating over strings. Fortunately, you can access elements in a string in other ways. If you need to perform operations on individual Unicode scalar values, the best way to do so is to use the chars method. Calling chars on a string separates out and returns 6 values of type char, and you can iterate over the result in order to access each element. So for C in and then a string dot chars, and then it allows us to print those all out, like to deal with those. This code will print the following. So that's what we sort of saw earlier, was that string slice. The bytes method returns each raw byte, which might be appropriate for your domain. So for B and this, print line B, okay. This code will print the 18 bytes that make up this string. So 224, 164, SNE. Okay, so the byte says each raw byte. Okay. I'm trying to understand like the snip here. Does it really put that in there? I kind of want to try that. I'm going to copy and paste that because I don't know how to put those characters with my keyboard in here. Okay, so this is going to be strings. So iterating function iterating. Oh, you ruined my tabbing. All right, so let's try this. Cargo run. I mean, that looks like just the raw bytes. There was no, like, I mean, it has the comment snip in there, but it's like really, like, we can't actually see that because it wouldn't print that out. Oh, snip. I get what they're trying to say. That they took the output and snipped it away. Because at the very end, we do have this 135 down here. So they're basically showing like the first one or two. They snipped out this from the output for us as the readers of the book. And they do this. Be sure to remember that valid Unicode scalar values may be made up of more than one byte. So there's this bytes, and then there's all the dot chars. So let's come back here. So iterating in bytes, and then we also have the exact same thing in chars. Which is right there. So my terminal doesn't have the right font to display whatever that thing that they said would be displayed out. Let's go. Okay. Getting grapheme clusters from strings is complex, so this functionality is not provided by the standard library. Crates are available on crates.io if this is the functionality you need. Strings are not so simple. To summarize, strings are complicated. Different programming languages make different choices about how to present this complexity to the programmer. Rust has chosen to make the correct handling of string data the default behavior for all Rust programs, which means programmers have to put more thought into handling UTF data up front. This trade-off exposes more of the complexity of strings than is apparent in other programming languages. But it prevents you from having to handle errors involving non-ASCII characters later in your development life cycle. Let's switch to something a bit less complex, hash maps. But we'll be getting to that next time because it is 7:56 and I am going to be getting ready for the rest of the day. Which is, at 8 o'clock or so. So what I want to do is come over to 8.3 hash maps, copy this in. Actually, we don't have to do, now that I think of it, I don't really have to do that. I'm going to quit out all of these. There's no more code open. Come back in here. Let's update the README. So now we're on chapter 8.3. Oh man, okay. I had tried to set up my caps lock as a control and then I did something, it was working, and now it's not working suddenly again. So that's a little bit annoying. Okay, so I have that, and I want to get status. All right, so we have our strings that we did. So like the strings we played with and the README. So git commit -m. Okay, so what did we do here? We played with strings. And now are on chapter 8.3. And pushing that on up. So I do have a link to this Learning Rust repo in the comments to both this live comments in the what is that thing? That's the description of this live stream, and I also have that on which is obviously going to be put over into the VOD as well. Now, I'm not streaming this on the weekends, so I hope that you have a great weekend. Next week, I'm going to do an experiment where same time, 7 a.m. Mountain Time, I'm going to experiment with streaming on Twitch TV. I will still be taking the video record, like the archive of that, and then exporting it to YouTube. So that way, I'll have it over here no matter what. So if you just want to watch the VODs, please make sure that you follow the channel, and that way you can see them in your subscription list. I will be posting a link to the Twitch live stream on Twitter, and I have a link to my Twitter account in the description to this video. So if you want to follow me over there, please go ahead and follow me on Twitter, and then you'll be able to get those announcements as well. Yes. Let's see. Averis, you mentioned maybe doing some pair programming later on. There's a pretty interesting plugin for VS Code called VS Live Share, which might be interesting for that. So I've tried Teletype, which is the Atom version of it, and it was okay. I did it for someone in person, and it worked, but it was a little bit delayed. I haven't tried the VS Code one, which, yeah, you're right. It might be really interesting. I've been watching Coding Garden, which CJ has been doing that with just web development. He's been having a little bit of trouble getting a remote person who's talking live, but also controlling the screen. There's just been a really bad lag for him, which makes it really hard to do that type of thing. I do have some friends here, like locally, that I can pull in to do that know Rust, and they can do some pairing with me here, like physically. So I might try that first, but I am definitely into experimenting with remote pairing. I think that would be fun as well. But with that being said and done, I hope that you have a happy Friday. And for me, the day is getting started. I know that some of you are. It is already ongoing. With that, have a great rest of your day. Have a great weekend, and I'll see you next week on Twitch TV and the VOD right here on YouTube. And click.